Okay, in this problem, we're asked to find the value of capacitance to be connected in parallel with the load to make the source power factor to be 0.95 leading. F is equal to 60 hertz. We're going to utilize our problem-solving strategy entitled Power Factor Correction. So our task here is we're going to connect a capacitor across the load to correct the power factor of the load and the capacitor. We want it to be 0.95. So here are our old values. So for instance, here's P old, and here's the power factor old. Okay, now if we look at our problem solving strategy, it says find Q old. So if we start out, we say, well, okay, let's calculate theta old. Theta old is cosine inverse of 0.85, and it's 31.79, and it's positive because we got a lagging power factor. So step one of our strategy says find Q old. So Q old is P old times the tangent of theta old. So we have 50 times the tangent of 31.79, and that's 31 kilovars. Okay. So there's the value of Q old. So we've completed the first step now. Let's draw a power triangle. So P old equal 50 kilowatts. Q old equal 31 kilovars. And here's this angle, 31.79 degrees. Now, we added a capacitor. Remember, capacitors, ideal capacitors don't absorb real power. So, P old should equal P new, 50 kilowatts. And theta new, we should get from the new power factor. It's going to be minus the cosine inverse of 0.95. Now, we asked to correct the power factor to 0.95 leading, and since it's leading, the angle's negative, so theta new is minus 18.2 degrees. So now our power triangle is going to look like this. And that angle is minus 18.2 degrees. So now Q new is P new, which is P old, tangent theta new. So we have 50 times the tangent of minus 18.2 degrees, which is minus 16.44 kvar. Okay. So now we've got theta new and Q new. So now step 4 says now calculate Q of the cap. Okay. So Q new minus Q old equals Q cap, which is minus omega C VRMS squared. So we have minus 16.44 minus 31 is minus 47.44 kilovars. So now we have minus 47.44 times 10 to the third is minus. Okay, now we have frequency of 60 hertz. That tells us the omega is 377. We're trying to solve for C. So we have 480 squared, and if we notice, the minus signs cancel out. And if we solve for C, we get 546.16 microfarads.